Hello everyone and welcome to a new discussion. It is in a continuation of our discussion on groundwater exploration, and this is part 9. Like in part 8 we have discussed that how geological structures play a very important role towards the exploration of groundwater and also occurrence of groundwater. What is the role of faults, folds and unconformity? These are three main geological structures at larger scale. And also earlier we have seen how fractures, erosion and other things play very important role. And further in this series of groundwater exploration, we will be seeing that what are the indicators of groundwater on surface which are available to us. And there may be some biological indicators, there may be some indicators like a spring is also one of the very important indicator of presence of groundwater. And we will also try to see that which plant indicates what and so on and so forth. So, let us start. So, in first part of this discussion we are going to have the indicators of shallow groundwater table and springs. See, since beginning of this groundwater exploration, I have been mentioning that our aim should be to minimize expenditure, and cost effectiveness is one of the reasons, because everywhere the test drilling or even geophysical methods of groundwater exploration is not possible or it becomes very expensive. So, the best thing is to exploit as much as superficial information available on the ground, and based on that then some at certain locations the next step, that is geophysical exploration, can be done, and after that at certain location test drilling may be done. So, the indications of shallow water table and springs which we will be focusing in the first part. Second part, bioindicators. So, as you know that the shallow groundwater is a condition where the seasonal high groundwater table or saturated soil is less than 1 meter from the land surface. Now, is a very kind of general statement. Some places 1 meter is too big depth, and at some places 1 meter is too little depth. But anyway, so when we say that water is available, this groundwater table is available at 1 meter depth, then we generally say shallow groundwater conditions. And where shallow groundwater conditions can occur even in a hilly terrain like this, that for a certain location here, like here we are saying shallow groundwater table, and here because from this surface, ground surface, topographic surface, we are calling as a deep, because here we are getting water at 1 meter depth, it may be 5 to 6, 7 or meter depth. So, in that reference, but these are in many times in such situations are there in a hilly terrain, and I will give you example of our this Shivaliks and Indo-Gangetic plain, and we are having a quite good belt of forest which is also called Rajaji National Park or Reserve Forest is there, and in this zone is also called Bhabbar zone. So, here the groundwater conditions are quite shallow, and even in monsoon time you may find that at some places water is there is a quite good seepages also. So, depending on the topography, vegetation cover and other reasons, we may get a juxtaposition. In the neighborhood we may get a shallow water table and a deep water table. So, the variation in the water table depth from areas where the water table is shallow and trees have plentiful access to the soil water, which is the left part, and to right part the areas where the water table is deep and out of reach of roots of many these such trees are there. But still forest is there, the sufficient amount of whatever is required is available, but here at a very shallow depth is available. So, different kind of plants will grow, and that can become our one of the bioindicators of groundwater conditions or shallow groundwater conditions. So, sometimes the indications of shallow groundwater condition and springs are also here, because of purged water table springs may occur there. So, suddenly we get the springs there because there is a eclude which does not allowing the water. So, if locally there is another water table has developed which is not to a large extent, So, here we get, and though in the surrounding you are having unsaturated zone, then you are having saturated zone and aquifer. So, springs can occur there, or springs can also occur elsewhere where the topographic surface is cutting your water table. So, the springs, rivers and lakes occur when the water table reaches the surface. This is, as recall that we said, direct indicators of groundwater conditions. So, direct indicators of groundwater conditions are springs, rivers, lakes, ponds. All these are the because the water table is near the surface. Groundwater entering rivers and lakes accounts for the base flow, which is like this. Base flow is coming and going into the river, or you say the effluent river, which are getting water from water table and from water levels in the water bodies. Water bodies here can be river, lakes and ponds and other things. Seepage is the scenario which I was mentioning. This is that area, Bhawar area, just south of your Shivalik or south of Himalaya, in a almost plain area. So, the Shivalik rocks can be seen here in the northern side, and this is the southern side of Shivalik, and see the water is coming out, oozing out. So, spring, seepage is a very good indicator of shallow groundwater conditions. Salt crust, sometimes we get salt crust, that means groundwater which was carrying salts were left, and due to the evaporation process the water has disappeared. So, it left the salt on the surface. So, a salt crust is also indicators of shallow groundwater conditions, and effluent conditions in streams are indications of shallow water conditions. That means the water table is contributing, effluent, the water table is contributing towards the stream. That is also an indication of shallow groundwater conditions. Here a Himalayan example I have been given, Babbar, so is a very generalized section. You see that when it comes the flat part, also some people call as tarai, but before that this is very coarse grained, as also you can see the boulders and pebbles and other things are poorly sorted sediments are here. This zone is called Bhabbar zone, and then you say the Tarai zone. Then there are other divisions also there. Bhangar zone is there, and then Kandhar zone is there, which is the river valley. So, this is the seepage which we see in many times, especially in monsoon season, is in the Bhabbar zone, is a region south of lower Himalayas and the Shivalik hills in Uttarakhand. It is the alluvial apron of sediments washed down from the Shivaliks. These are the sediments which has come from the Shivalik in the northern edge of Indo-Gangetic plain. So, these are the areas where you get water at very shallow depth, even flowing on the surface. And of course, another very important indication of shallow groundwater conditions of water table is spring, which we have earlier discussed in a 3-part series about the different types of springs, hot springs and types of springs and other things. Anyway, so very briefly we are touching from that shallow water table point of view or indicators of shallow groundwater conditions. The abundant small springs on valley slopes generally indicate a shallow water table and a poor permeability of aquifers. So, that we are getting water on the surface. Another example of this spring is a natural spring, which is Sahasdara. There are thousands of these small are coming. Now, lot of development, modifications and human interventions have been done. Otherwise, we used to see that drip by drip at thousands of places, and there were springs at all location or water was dripping out of that. It is a limestone terrain. So, in contrast, large aquifers confined to the valley bottoms indicate high permeability and greater depth to water table above the springs. And the springs, because of course, the topographic region is one of the reasons for formation of springs. The geological formations or geological conditions can also create springs. Like here, what you are seeing on the left side, and that it is this is impermeable clay layer is there. So, this is the fracture basalt. The water is coming here during the monsoon time or rainfall, but it is not going beyond this impermeable layer, which is a fine grained sediments, clay layer, and therefore you are seeing springs here. But suddenly there is a permeable layer, and which may be getting water or recharge from some other source. So, some springs, limited springs you may find here, because below which again you are having impermeable. So, this kind of geological setup, though all are horizontal bedded or homoclinal, there is no inclination, nothing, just simple horizontal bed, but still at different locations because of impervious and pervious layers you may get springs. Similarly, here you are having on top a permeable sandstone, and then impermeable shale rocks, fine grained sedimentary rocks, and therefore you are seeing springs are coming here. So, springs are controlled by impervious layers in the valley slope. So, the presence of several horizons of springs along valley slopes may indicate permeability stratification. That means some rocks are highly permeable, some are impermeable, or you are having a series of rocks which is pervious, impervious, pervious, impervious kind of situation. So, permeable stratification controlled by lithology, geology, or overall geology or lithology or structures. So, under these conditions or favorable conditions of land surface slope and the dip of beds, artesian aquifers may support flowing wells. So, getting artesian conditions is not easy, but there are places, even I myself has seen in Sonbhadra district very clear artesian wells also there. So, there are many places you can get, even in Bhabbar zone also artesian conditions can occur, or in some even in Bundelkhand area I have seen during monsoon time some artesian conditions because of water table is going very high, and a downstream of a reservoir you get for some time artesian conditions. So, these basically they may occur like this. Now, we will based on this shallow groundwater conditions that influences our water quality also, because lot of things which are coming from the surface, or if I say pollutants, they may get into the groundwater regime. So, that is also affects our groundwater quality. So, that we will be also just touching here, but there will be complete separate discussions on groundwater quality and the parameters. So, another important facet of groundwater exploration is the enable prediction of the quality of groundwater. Groundwater might be available, but what is the quality, whether it is consumable, drinkable, potable, a better term is potable, whether that water is potable or not, that is very, very important. So, on the basis of topography and drainage system, the recharge and discharge areas can be identified, and like here we are finding that there are recharge areas, there are discharge areas are there. See, these are the recharge areas are there, and then discharge is occurring here, and these are effluent river streams are there, and so on. But in between, if there is a geologic formation which is having contaminants or not good from groundwater point of view, then that will also enter in my well or this bore well, but the river might not be having influence of that at all. So, sometimes the condition of water table also plays very important. If in this situation the water table would have been at a lower depth, then probably the effect of this contaminate bodies may not affect. So, or maybe minimum. So, that kind of understanding is required to understand or estimate about the quality of water. So, the fresh water usually recharges aquifer because your rainfall, and whereas more mineralized water is discharged, as we are seeing here, because of certain geological arrangements or types of rocks which are there. So, if we look this groundwater quality from northern Indian or Indo-Gangetic or Himalayan region point of view, then this is the distribution of groundwater salinity in the top of 200 meter of Indo-Gangetic basin, which we are seeing here. And that what is the quality, and this is based on the TDS, total dissolved solids. So, in the northern part of Indo-Gangetic plain, the total dissolved solid is relatively quite low, whereas in southern part and on western part of Indo-Gangetic plain, the total dissolved solid is at very high. So, this is basically controlling our one of the parameters which is considered in groundwater quality is TDS. So, salinity distribution, now how it is controlled may be modified by local geology, soil, water table depth, direction of groundwater movement, surface water bodies and human interventions. Human interventions, if there are some discharge into the groundwater which is having the water which is having pollutants because of some industries or from sewer and other things, they may also deteriorate our groundwater quality. So, sources of salinity from evaporation is often seen on the surface by salt crust. This we have already discussed, that is also indication of shallow groundwater conditions. And there are areas in Punjab, Haryana where intense irrigation is done, and that means the shallow groundwater conditions, and there is no proper drainage system, and therefore, whatever the fertilizers and everything which are being put in the agriculture field, because of shallow groundwater conditions, because of this evaporation, the salt is left on the soil surface and water disappears, and that creates a salt crust, and then that agricultural field may become completely unfertile, useless. So, lot of then treatments are required, and one of the, because of capillary action, capillary rise of water table and water at the surface, and then evaporation process brings the salts from the depth on the to the surface. So, if we in such areas, if we maintain like these areas which I am just mentioning here, if we maintain the deeper groundwater water tables by some means, then probably this total dissolved solid or salts will not be or salt crust will not be there. So, one of the solution, but naturally plus because of irrigation, because of agricultural practice and crop cycles, this groundwater conditions in many areas of Punjab and Haryana has become saline and alkaline areas because of this salt crust, and creates a lot of problem in the production. So, further the soils also plays very important role in such situations. So, clayey soils and shallow groundwater conditions may indicate of salinity of groundwater, because these clayey soils are not allowing the complete water going downward, and shallow groundwater conditions is there, water is not going down, and because of capillary rise water is coming, bringing salt, water is getting evaporated, salt are left on the surface and creating salt crust. So, if we know or we can identify the sources of salinization and saline zones are identified, contour maps of piezometric surface or water table as case may be will indicate the direction of movement of saline water in the aquifer as shown here also. That we know this is the source of saline water, this is the direction of, because of contours of water tables, these are the direction which have been identified. So, if a well is here, then it is going to have saline water, but if wells are here, then they will not have saline water. So, this is very important, the use of water table contours to predict extent of saline zones. So, A which is marked here is a saline intrusions of streams bed, B is the outcrop which we are seeing here, these are the outcrops of bedrocks, C is the water table which you are seeing through the contours, and D is the fresh water flows, D is the fresh water flow which is flowing across the contours in subsurface conditions, and E is the direction of movement of leach salt which is here in the downside. So, F is likely to strike fresh water, but cone of depression likely to capture the least salt. So, these are this situation is here, and this situation is here, and G is the well likely to strike saline water. So, if we go for a bore well in this, then we are likely to have the saline water. So, better understanding of an area can predict that what is the groundwater quality one is going to have in his well. no matter whatever these conditions are there. So, if some way by means, if option is available, if it can be avoided, then a well in other side may provide you better water quality water than in this part. Now, elevation difference maps of potentiometric surface heads in the different aquifers will show the direction of interchange of water table, water of different qualities between the through the aquitars also. So, that kind of what I am trying to say here, a better understanding, suppose this is my study area, then full knowledge about that area is required to understand where I will get more fresh water, where I will get saline water. So, this kind of salinity distribution, trends, flow of direction, bodies which are saline bodies can create saline water, all is required for that. Now, the last part of our this discussion that is about the bioindicators. What are the bioindicators? That is the utility of plants or these trees or bushes and other things which indicate the groundwater conditions or water table conditions, which was realized in much earlier in the 6th century AD. But the subject has not received much attention both in the by the botanist or by the hydrologist, because these bioindicators sometimes are not reliable at all, and that is why the much attention was not paid. Anyway, nowadays lot of research is being done about bioindicators, and the plants which use different level of water or different quantities of water, and based on that lot of classifications are being incorporated nowadays. So, because of the subject lies in the borderline between these two disciplines, that is botany and hydrology or groundwater hydrology, and then because may not have practical significance in many of regions and environment. And further is the plants that are useful as indicators of hydrogeological conditions are called hydroindicators, and this is what we will be discussing in this section. So, with respect to water environment and transpiration, because plants will have transpiration, but the overall what we estimate is evapotranspiration, because from the soil surface or open surface we also get evaporation. So, a total quantity which we measure is evapotranspiration, and does not matter. So, the water environment and transpiration plants can be classified into 4 categories. About these bioindicators, in recent years much better understanding is coming, and depending on these environmental conditions, water availability conditions, people have started growing plants like that also. So, hydrophytes are there, one types of plants which are aquatic plants, grow in the water, that are especially suited for living in aquatic environment. And we know in India very famous plant which is lotus is a hydrophytes. Now, pteridophytes plants are, which is a deep rooted plant, and deep root means they are looking for water at deeper conditions, obtain a significant portion of water that it needs from the pheretic zone, and that is the zone of saturation or capillary fringe above the pheretic zone. So, these kind of plants are called pteridophytes. They are generally in a very dry area or areas where the water table at a great depth. And further is the mesophytes. Mesophytes plants and xerophyte plants we will see very soon. With respect to water environment and transpiration, plants can as we have seen that these can be classified. So, now the mesophytes plants are that these are the terrestrial plants which are neither adapted to particularly dry nor particularly wet environment. They can grow in very different water conditions. These are called mesophytes plants, a kind of mixed kind of plants. And further is the xerophytes plants, which are the mainly the cactus can put in this category. Xerophytes from the Greek xeros, that is the dry, and phyton means plant, is a species of plant that has adaptations to survive in an environment which is very harsh and little liquid water, only the water which is available in the atmosphere, and these grow in desert or an ice or snow covered regions. Like we are having like desert areas, there are two types of desert. One is a hot desert like Sahara deserts, or our in Jaisalmer area in Rajasthan we are having completely hot and dry deserts. But there are cold deserts like in Ladakh region we are having cold deserts also. So, there not much plants are growing because the water is not available. One, and whatever is plants which are growing, most of these are getting water from the atmosphere, and but the humidity, the atmospheric water is also very little. So, if I compare the humidity, normal humidity in Ladakh area, it is 15%, and if I compare with Roorkee, it is average might be 75% humidity. So, that kind of difference is there, and therefore, these plants are indicators of groundwater conditions. We are not discussing from botany point of view, but we are discussing from groundwater point of view. So, hydrophytes plants are there, that means they are available, lot of water is available. Phanerophytes, that we are having a very deep groundwater table, and mesophytes may not indicate much about the groundwater conditions, but xerophytes are telling that nearby surface there is no water table or water available, whatever these plants are surviving through the moisture which is available in atmosphere. So, recently, as also I mentioned, that recently now attention is being paid, a considerable attention has been focused on phanerophytes plants in context of conserving water resources which is lost by non-beneficial consumptive use of many species of phanerophytes. And then one of this benzoic giant powerhouses in Himalaya which is there, which is a good indicator of groundwater conditions. So, people say in Himalaya or in say in Garhwal Himalaya, if they find this oak, and they say that the groundwater conditions might be good here. So, bioindicators is possible to quantify the groundwater lost by conjunctive of considering the diurnal fluctuation, that means the within a day in 24 hours day and night diurnal fluctuations of the water table in phreatic wells or water levels in pools amidst phanerophytes. And this kind of equation has been developed which tells that how the water table changes. So, in a diurnal basis in fluctuation, because of these plants are taking water, not taking water, and the processes of and this transpiration reduces or increases accordingly, these kind of changes can also be there. Further, it is also possible to infer roughly the depth to the water table and quality of groundwater by the types of phanerophytes which found in an area. And however, there are limitations, of course, these are just indicators, not conclusive. So, there will be some limitations of using phanerophytes plants as indicator of availability of recoverable groundwater, because phanerophytes plants can abstract water from saturated clays. And remember, the clays may have a very good porosity, but very poor permeability. And these phanerophyte plants can get water from even clays. So, if phanerophyte plants are growing, somebody may say that the groundwater conditions are good, but clay is not very good from groundwater point of view, because it does not have much original permeability or intrinsic permeability. It might be having a secondary permeability, that is a different thing, and fine silts which will not contribute water to a well. So, that becomes one of the limitations of phanerophyte plants. Moreover, these phanerophyte plants cannot serve as indicator in identifying aquifers below root zone, because the root will not go and these kind of plants will not grow. So, if you are having deeper groundwater conditions, you may not. Further, these may not be useful in artesian aquifers, salinity stratification, main use of saturation below purged aquifer. So, of course, these are indicators, these are not conclusive, they can be used along with some other data sets to find out the groundwater conditions or shallow groundwater conditions. Now, at one of the examples I said of shallow groundwater constitution a concern, a problem in many parts of even India. We have been so far talking about deep groundwater and non-availability of water, water available at greater depth. But there are problems of shallow groundwater conditions, as I also gave example in some places in Punjab, Haryana, and because of salt they are bringing and basically ruining our agriculture production. So, and also these waters becomes easily polluted also. So, removal of some pollutants, for example bacteria, can occur in Vadose zone beneath the base of the BMP, that is the best management practice. See, the water usage of water has to be very judicious in all conditions, whether you are having a shallow groundwater condition or deep groundwater condition, and this is very, very important to in groundwater, shallow groundwater conditions, some problems like salinization, alkalinization of soils can become a big problem. And of course, this is pollutants also can become. So, this best management practice is a method to use, prevent or control stormwater runoff and discharge of pollutants which is going inside our groundwater regime or aquifers. So, these pollutants should not even go to local water bodies, because ultimately these ponds, lakes and other things, they are indicators of shallow groundwater conditions, and if these are polluted, then that means our groundwater will also get polluted. So, therefore, the flow of these pollutants should not be towards these water bodies, surface water bodies. So, there are like silt fences, if possible, can be created, inlet protection can be created, site stabilization techniques are typical BMP's practices, constructive sites. So, pollutant removal, now if there is already pollutant present in the water, then how it can be removed. So, pollutant removal in the Vadose zone is attained by biological activities, chemical degradation, absorptions of pollutants through soil and plant uptake. So, in such areas plant uptakes, you know that a eucalyptus plant, for some areas it is quite good, but for many areas it is really bad, because it consumes lot of water. But areas which are having shallow groundwater conditions, such type of plant species will lower your water table, will reduce the salinity, will not cause the salinity or will not cause salt crust. So, any such plantation, the biological treatment of such should be very judicious and very scientific. Then probably such kind of balance can be maintained, that we do not have very shallow groundwater conditions in the soils which are clayey soils and which will create problems of salt crust and other thing. Shallow groundwater conditions also reduces the depth of the unsaturated soil available for treatment, leading to an increased likelihood of groundwater contamination. So, that also creates, I have already mentioned that shallow groundwater regime is more likely to get polluted than a deep water regime or deep aquifers, because they are directly, almost directly connected with surface water bodies, and if surface water bodies is polluted, then your groundwater regime or water aquifers may also get. So, Vadose zone is further reduced when a groundwater mounds forms, and these sites present challenges to stormwater management, and however these challenges can be managed. Technology understanding about such things have been developed. So, here like here it is infiltration, BMP, best management practice is done, and building or surfaces are there, the water is going down, and this is a mound of water table, higher or shallow groundwater conditions are there, the basement rocks are there. So, that kind of management can also be done. Now, when we are doing or trying to understand these shallow groundwater conditions and doing such investigations, then our investigations should also include soil surveys, because soils are important. Clayey soils are not favorable or bad from groundwater point of view on the surface. In shallow groundwater conditions I am talking. So, because clayey soils, the permeability is poor, porosity is higher, and they are not good. So, investigations should include soil surveys, of course geological atlases or geological maps, or well records should be used to determine well record whatever the wells which are present in an area, what is the water level, what is the pre-monsoon, what is the post-monsoon in case of India. So, how water fluctuates, that all if it is available, then we can determine the likelihood of the groundwater table is shallow or not, or will become shallow in certain months of the year during monsoon or not. So, that kind of analysis can be done, that kind of investigation can be done, and such salt crustacean, salinization or pollution to water bodies or a pollution to aquifers can be avoided. So, finally, if a shallow groundwater table is present, suppose it is there, we do not have much choice, a geotechnical investigation then should be conducted. So, that like earlier we have discussed, a wall can be created and so on and so forth. But such kind of are very local solutions, may not be for an area. So, for an area, if we are trying to resolve this shallow groundwater conditions, and directly we are trying to solve also this salinization and other things, in such areas the water table should be kept at optimum depth, not at a shallow depth. If that is maintained by some means, less irrigation and planting plants which are consuming lot of water like eucalyptus and poplar and other things, then probably we can maintain water table at a optimum depth, and which will not harm our soils on the surface, will not bring salts on the surface, and then agricultural practice, good agricultural practices can go on. So, good water management or water table management, good practices of water table management can also have good agricultural practices. So, with this I end this discussion. Thank you very much.